In this video, I'm going to be taking the determinant of a 2x2 and 3x3 matrix. The most important thing about taking the determinant of a matrix is knowing that it must be an n by n matrix. And this means that the matrix is square. So an n by n matrix would be, for example, 3, 4, 2, 9, and we can see that is a 2 by 2 matrix, hence the term n by n. A matrix that isn't square would be something along the lines of 3, 6, 3, 7, and 4, 9, because it only has 2 columns and it has 3 rows. So this is not an n by n matrix, which means you can't take the determinant of this matrix. Taking the determinant of a 2 by 2 matrix is pretty straightforward. We can see that this is an n by n matrix because it has 2 columns and it has 2 rows, which means it can have the determinant taken of it. And if you look down here, this is the formula for the determinant. It is a1b2 minus a2b1. And the easiest way for me to remember this is if you draw a line here and then draw another line here, you're going to have a1 times b2 minus a2 times b1. And that is what's shown down here in this formula. So let's do a quick example. Let's take the determinant of the matrix 3, 7, 4, 9. Based off of this formula, we can draw some lines here. We have our line going this way and our line going this way. So we can do 3 times 9 minus 7 times 4. See, there's 3, 9, 7, 4 in our corners, and this is going to be 27 minus 28, so our determinant here is 1. Let's do one more example before we move on to the 3 by 3 matrix. I'm going to take the determinant of this matrix here. This is a 2 by 2 matrix once again, which is a square matrix, and let's go ahead and draw our lines here and here. And this is going to be 2 times 4 minus 6 times 3. You can almost even draw a path here like this. 2 times 4 minus 6 times 3. And this is going to be 8 minus 12. So our determinant is going to be negative 4. Let's move on to a 3 by 3 matrix. This is a bit more complicated, but it's very similar to taking the determinant of a 2 by 2 matrix. Looking at our equation here, we have a1, a2, and a3 all in front of 2 by 2 matrices. And the way we do this is you'll always be multiplying by your top row here in this main 3 by 3 matrix. So let's start with the a1 term here. How do we calculate this? So we get this by choosing a1, and we're going to eliminate the row and the column from A1, which means we're left with this 2 by 2 matrix down here. And this 2 by 2 matrix is identical to this matrix that's down here on the right. So what you're really doing is doing A1 times this matrix. And as we move across the top, it goes the same for A2. So we have A2. Let's go ahead and eliminate that top row and the column that A2 is in. We're going to combine B1C1 and B3C3 and put them down in this matrix down here. So we have A2 times the 2 by 2 matrix of this. And as you probably guessed, when we select A3, we eliminate that top row and the third column, and we are left with this matrix down here, because we have this 2 by 2 matrix remaining on the bottom left. And the process is very similar to when we just took the determinant of that 2 by 2 matrix above. So this first term, for example, we have B2 times C3 minus B3 times C2, and that shows in this formula down here. So essentially, if we just ignore this A1 that's out front, we're just taking the determinant of this 2 by 2 matrix once again and multiplying it by A1, which is our leading term. Let's do an example of this real quick. So we can say that A equals the matrix 1, 6, 4, 3, 7, 9, 2, 4, 3. So let's solve for the determinant of A. Select the 1 in the top left corner here, eliminate the row and the column, so we get 1 times the matrix that is remaining down here in the bottom left, so 7, 9, 4, 3, and that is our first term complete. We always subtract the second term, so if we select the 6 in the top here, we're left with the matrix 3, 2, and 9, 3. So it's going to be minus 6 times 3, 9, 2, 3. And that's our second term completed. And we can go ahead and finish off with our third term. Select the 4 in the top right, we're left with the matrix. Select the 4 in the top right, and we are left with the matrix 3, 7, 2, 4. And once again, like we said before, this is just like solving a 2 by 2 determinant matrix. So we get 1 times, draw our lines here going back and forth, 7 times 3 minus 9 times 4. And once again, let me just reiterate, there's always a minus sign here and a plus sign here when you're taking the determinant of a 3 by 3 matrix. So this is minus 6 times, draw our lines, so this leaves us with 6 times 3 times 3 minus 9 times 2. And let's bring the 4 out, and we get 3 times 4 minus 2 times 7. So when we go ahead and solve this, we get 1 times 21 minus 36 minus 6 times 9 minus 18 plus 4 times 12 minus 14. And after collecting a few terms, this is going to leave us with a final result of 31. So what if I told you there's an easier way to go about solving these matrices? There's a way we can actually just completely disregard this second step here, and we don't have to rewrite those middle terms for the matrix. So if we take a look at this one more time, there's actually a pattern going on here. And you might have seen this in your statics or strengths class already, maybe even dynamics, when you're using the I, J, and K terms across the top. So what you can do is select your top left term here, and you can just go ahead and draw your lines straight into this matrix. So just looking at this, we're going to get A1 times B2 times C3 minus B3 times C2. And that actually matches our exact term down here in the bottom left. Completely disregarding this middle step here, where we're rewriting everything. Just make sure you have a good handle on matrices before you go ahead and do this. So let's use that method in an example. I'm going to be using the same matrix that we used down below just to prove to you that we do actually get the exact same answer. So once again, let's select our top left corner, draw our arrows, and we get 1 times the summation of 7 times 3 minus 9 times 4. Select our sixth term here. And this is a little bit tricky because the numbers are on the opposite side of the matrix here that we're selecting. Remember, we're canceling out this top row and this middle column. But what you can do is draw your lines across like this. Draw them across. So this is going to give us, and remember the second term are always subtracting, so negative 6 times the summation of 3 times 3 minus 9 times 2. Notice how I just track these numbers across like this, and it's just like we're doing a big 2 by 2 matrix across the 3 by 3 matrix. Alright, now go ahead and select this top right term, and we can draw our lines once again. So this is plus 4 times the summation of 3 times 4 minus 7 times 2. And after doing some math, this does come out identical to the matrix that we had below, if you remember, was 31. I hope you learned something today. Alright, and that's how you solve the 2x2 and 3x3 matrices. Just keep an eye out for that 4x4 matrix video soon. I will be releasing one.